Hello and welcome everyone to another Silicon Labs Talking Tech podcast. As the title indicates, this episode is going to teach you all about Silicon Labs' latest software announcement, the Unify SDK. Hopefully you will learn some details about how this new offering can accelerate your next IoT project. Joining me to help provide answers are John Hemmick. He's a software applications engineer involved in the gateway solution. And also Uday Kelkar, he's the product manager for the Unify SDK and making sure everything's ready for you as listeners to digest it. So thanks to the two of you for joining today.
Thanks, happy to be here.
Thank you.
All right, well, again, thanks for taking the time to help the listeners learn a little bit more about the Unify SDK. So I'm gonna start it off as I do with every podcast. If you were in an elevator, John, and you had to explain to the person next to you what the Unify SDK is, how would you answer that question?
I'm almost sorry for someone trapped in an elevator with me asking that question. There's a lot to say, but I guess to try to keep it concise and at an accessible technical level, I like to think of the Unify SDK as like the steering wheel and gas pedal and brakes for the IoT, right? It's essentially a collection of software that is going to allow your things to be controlled with a simplified common language rather than the current patchwork of all those little hubs that people have in their closets currently next to their router. So you're getting rid of all of those and just controlling through one interface. Unify intends to replace all of those with this really great software language, the UCL. So essentially, what we've done with Unify SDK is to take all of the protocol-specific work out of IoT thing makers process to try to help our customers accelerate their product to market. You can think of Unify as like a high-level scripting language for the IoT, and one where our protocol experts have taken care of all of the harder parts of, say, Zigbee, Bluetooth, Z-Wave, that sort of thing. And they've attached it to a really cool MQTT-based common language that's going to allow makers and manufacturers alike to perform all of the standard activities that you'd want, such as adding or removing or controlling devices without needing to learn a bunch of protocol-specific APIs individually. It's like a one language to many network solution. And that is the shortest explanation I could manage in an elevator. I hope I still have time.
Yeah, well, I think we're in a tall building, so it's all right. But okay, so essentially what you're talking about is a scripting language or an API that's going to provide a common command so that customers can take advantage of all of our expertise with these IoT protocols without having to get into the weeds of all those protocols and control languages.
Yeah, that's right. We've tried really hard to take all of our experience from, the Zigbee cluster library and everything that we've learned with Z-Wave. So we've got a large body of experience controlling things. And so by abstracting this out to an MQTT interface, which is really well known and really well adopted in the IoT space, we're hoping that people will have an easier time connecting to things because at the end of the day, that's kind of what everyone is after. You want to control your network. You don't want to have to sit and learn APIs.
Absolutely. So that leads into my next question. So what does the initial release in September provide to the customers? What IoT protocols are we tackling for them? I think you mentioned it, but why don't you just go into a little bit more detail about what the initial release of Unify SDK provides our customers?
Yeah, absolutely. So right out of the gate, when we released in September, Unify supported Z-Wave and Zigbee, but we do have plans to add other wireless protocols in the future. Unify is actually leveraging and extending the ZCL, the Zigbee cluster library. And the reason why we've done that is that the ZCL has a lot of definitions for the standard sort of devices and their typical behaviors. For example, light switches, thermostats, all of these things. Because Zigbee has been in the market for so long, a lot of the behaviors and device types are already specified. So what we've done is we've utilized the ZCL and we've mapped those behaviors and clusters onto MQTT-based common language that we call the Unified Controller Language. And Unify is going to support a lot of sort of the standard devices and use cases that you'd need for controlling IoT devices right out of the box. Our software is going to handle the translation between UCL to protocol specific commands and handle all of the network specific behaviors through these modular components called protocol controllers. So it makes the product really extensible. So when new support is coming online, you'll have the same interface on the top and you can just plug in a new protocol controller, say for your Bluetooth mesh or whatever you end up needing to support as soon as we've got support available for it. And you can check out our current release notes on GitHub for more information. But I can say right now, we already have support for a large number of different clusters right off the bat. For example, we have alarms, firmware updates, binary sensors and switches, batteries, door locks, sensors, including CO2, water, and I think fire. We have multi-level sensors, illuminance and occupancy, and on-off for Z-Wave, as well as identity groups, on-offs, multi-level, door locks, thermostats, color control, and occupancy for Zigbee. So I know that that was a bit of a mouthful, but that's currently supported, and you can get that, like I said, on GitHub. And we plan on releasing more with every release in the future. I hope that answered your question.
It did. And I think just that long list shows exactly what the value is. I mean, out of the box with a simple language, they get access to all of those types of controls. And I think one thing you mentioned was Zigbee and Z-Wave, and it's common. So they don't have to learn a different command or control sequence for different protocols. They just have to learn R1, and then we take care of it and go into the specific protocol controller that you spoke of.
That's absolutely right. And we also have some examples. The GitHub contains documentation that you'll need to get started, and as well as some little sample apps we release for people to test with.
Okay, so you've talked, I think now we have a good understanding of what it is. Why don't we go a little, I know you're in the apps team, so you can go a little deeper. Why don't we go deeper on, you mentioned MQTT, you mentioned protocol controller in your last answer. Why don't you talk about those building blocks and exactly how we're achieving this unified control language?
Okay. Well, the major modules of the Unify SDK so far are going to be GUI. We provide a dev GUI that allows people to evaluate the sort of standard behaviors of the Unify SDK, but it's also sort of a reference for what we believe our customers will use our Unify SDK to build, right? So it's kind of like a jumping block. We also have an over-the-air image provider, which is a software that allows people to manage and maintain firmware updates using this MQTT interface. We have the Unify SDK provisioning list, and that's sort of this Smart Start abstraction layer that allows you to support Smart Start on all of your networks. So you may be familiar with Smart Start if you're coming from ZWare land, but basically this is your device key and security authenticating devices. In addition to that, we have two protocol controllers, like I mentioned, at launch, which are going to be ZigPC and ZPC. So those are the sort of major blocks. So at the top level, we've got this UCL, the Unified Controller Language. And basically what this is, it's a description of these devices and their behaviors. Again, its heritage comes from the cluster library, Zigbee cluster library. But our UCL also defines the payloads that you're going to use, and it takes these devices, these clusters and their payloads, and specifies MQTT commands. And the reason why we've used MQTT here is it's this very popular pub/sub messaging protocol that's already super popular and extensively used in the IoT. So the UCL is going to allow high-level software, which in our SDK, we refer to these as IoT services. It allows these IoT services to interface with end users. And these could be either like cloud services, but we also mean services as in local services. You can think of the management interface of your router. You type into your browser the router's IP address and get this little control GUI. So in addition to that, we have these services which are going to be emitting these commands in UCL. Unify is going to take these commands and then translate them into the network specific packets that need to go out to control things. And I mentioned briefly at the summary at the top, protocol controllers. We have a ZigPC and a ZPC currently. And basically what the protocol controller is the translation layer from UCL down to your protocol specific payloads. For example, Zigbee, Z-Wave, Bluetooth, that sort of thing. The protocol controller is going to translate maybe one UCL command to one protocol specific command, but it also does one-to-many, and it handles things like retransmissions and all of the sort of more complicated protocol specific logic. And then finally, I will say, because we are writing both the APIs and these protocol controllers now, the benefit with sort of streamlining this, or one benefit of streamlining this, is that you have our experts, the ones who wrote the APIs, now actually using the APIs. So before, in the pre-Unify SDK development process, you'd get an API, right? And you'd get some documentation, and you'd have to go in and figure out how to use it. One of the great things about protocol controllers, I think the greatest thing, is that now our experts are implementing using their own APIs. So you get sort of better performance, and you get the APIs used in a way that they were intended to be used without having to figure it out kind of through reading documentation and trial and error. One of the big things that I guess customers ran into in the past was, not using an API the way that it was intended, either through bad documentation or just things are just not quite clear.
Yeah, just adding that one layer of abstraction, at least at that protocol controller layer, will be huge, because I know that's a huge stepping stone for a lot of our customers. Uday, do you have anything to add to that?
Yeah, definitely. I think John covered it well, the different components and modules and services, how these things are coming together for Unify. One thing I want to highlight, that since the beginning of Unify, we kept the modularity and the API and interface-driven architecture. The key to that is that allows the developers to integrate Unify and further customize and make it suitable to their designs. And it also makes it future ready, that if any of these protocol controllers or any of these components we evolve, or customers and designers, they want to evolve, it still kind of keeps that compatibility and make the Unify system as a whole. And that keeps it also future ready as we develop more components for Unify. So that modularity right from the beginning with the architecture and define interfaces, and as an integration point for the designers to build Unify into their design, has been the key. So then that applies to all these components, and John covered it well. So, yep.
All right. Well, why don't we? This one of my last questions is, what are some of the initial customer engagements? What are they using this for? You've seen them integrate the software into their products. What benefit has it provided them in the early going?
From my perspective, working on the support queue for Silicon Labs, I will say a lot of our early adopters, even if they're not doing something like multi-protocol support out of the gate, we've seen a lot of adoption for Unify SDK simply because of that process that I mentioned earlier, where we've simplified out all of the hard work of the protocol and have allowed people this much, in my opinion, much nicer uniform interface. So a number of our alpha customers are currently just on the Unify SDK because it's a lot simpler than, say, the C API for Z-Wave or the Ember ZNet for Zigbee. So if our customers don't need to handle things like packet retransmissions or opening application sockets or any of the protocol specific behavior, they can really just hit the ground running and get their products to market faster. It's leaving the work that we're good at Silicon Labs, the expertise that we have, it leaves that work with us and allows our customers to do the work that they have expertise in, which is, their devices and their services, right? Their cloud services and their web apps, et cetera.
Yeah, I think that too many times when customers are looking to get into a protocol or into a space, going from the ground all the way up, every single customer having to master those low-level protocol controllers is time intensive and support intensive. And so going back up, like you said, to that upper layer, a little bit more common software interface has to be more helpful than, as you mentioned, some of our prior C-based libraries.
That's absolutely right. And after a certain amount of time working in applications, you tend to see the same questions being asked over and over again. And if people are having kind of the same problems starting from the bottom and going all the way up to the top, I think it's really good that we took that feedback and have sort of provided something that will hopefully eliminate some of that duplicate work.
All right, so you've gotten our listeners interested and they like everything we've said. So how do they get started? What software or hardware is required for them to start evaluating everything we've told them is great?
Well, right now you do need to accept a license agreement, the same license agreement as our WSDK. So you do have to download and install Simplicity Studio. But after you've done that, currently the process to gain access to the Unify SDK reference is you will open up a support ticket and either myself or one of our other apps engineers will add you to our project on GitHub. So if you submit your GitHub username after you've agreed to our Simplicity license agreement, we'll add you to that GitHub project, and then you can just go ahead and pull that project and get started. Our initial reference is designed to work with Cortex-A style microcontrollers running Linux. Internally, we use the Raspberry Pi running Raspbian, but you can use any similar microcontroller running Linux or compile it for your own platform. It just may not be as supported from the start. But if you run into any problems, you can, of course, submit a help ticket. And then with our provided software and a suitable platform, and let's say a couple of our WSDKs with daughter boards like ZenGecko and a Mighty Gecko, you can actually get started right off the bat doing really cool things like you could control Z-Wave Light with a Zigbee switch using UCL. Or you can just start sending and subscribing to MQTT topics and seeing all of this traffic and all of these devices working. So it's really easy to get off the ground, and thanks to the well-defined and well understood MQTT based interface, it's actually pretty easy to start digging into the inner workings and really have an understanding of how this is going to operate.
All right, well, that does require a little bit for our listeners to get started. So I'll take the lead and I'll put some of those links in. I'll put a Simplicity Studio link and the support ticket link into the podcast description so our listeners can jump into it. And I do know we did a training in the past. Actually, John, you put it together and it was really helpful. So I'll work to make sure in the next few weeks that that'll be put up on our website. So if a listener is interested, they can download Simplicity Studio, they can put in the support ticket, and then hopefully that training will be on our website for people to get started. Anything before we close, Uday?
Yeah, I think John mentioned it earlier. One of the other thing is the developer app as a good reference point. It kind of gets you a good starting point with all the to exercise across this solution development, design development, and that's the intent of that GUI, the developer app, and that's something. It's a good reference point and will help you to get started.
Excellent. All right. Well, this has been terrific. The two of you have done a great job. You've provided enough information, I think, for all of our listeners to be at least interested. And so again, the call to action would be for those of you that are interested, take the time, install Simplicity Studio, register to get access to the Unify SDK, and then you'll most likely get connected with John and his team to answer some of your first level questions. So as usual, thanks to all our listeners for taking the time to download the podcast and listen today. And until next time, everyone, stay safe.